Can I revert Lisa from BLACKPINK in 3D? What you are seeing right now is not a simulation or a render. It's a fully animated playable character. That means no render times and no waiting for cloth caches. That's the advantage of working in Unreal Engine. In today's breakdown/tutorial, I will show you first how I designed the garment using CLO3D/Marvelous Designer. And after that, I bring the garment to Unreal Engine using the CLO Live Sync tool and importing it as chaos cloth. Means they're converting some parts into real-time animation using the weight paint. And also to complete the look, I show you how I rig the shoes to the avatar. And I do everything in CLO and Unreal Engine. No more need of using Blender, no more need of using additional software learnings. And the goal of this tutorial is to show how digital fashion can move from static images and high polished renderings into interactive characters. And there will be also a part 1 where I will show you how I create the high quality avatar using a MetaHuman as base. And again, there's no modeling needed, no texturing, a bit of texturing. I show you also texturing there in Substance Painter. But other than that, it's a really easy setup. You can just follow along. So also check the link somewhere in the corner. And you decide at the end if this is worth it and if the character really looks like Lisa. So let's start. Okay, before we start, you probably recognized that this look is not a normal look. It's actually a shoe. And I just saw this worn by Lisa last week in my feed and I thought I need to recreate it. And it's from the label I Wanna Bangkok, which is doing really fun stuff. So also check out their website. And also I'm starting actually in Unreal Engine because I want to download the new, I don't know if it's new, MetaHuman DNA, which helps me to refit all my garments immediately to my MetaHuman. Does not matter where they're coming from. And I can use just styles as a base from CloSet Connect. I'm in the MetaHuman character creator and I just open in the tab menu the MetaHuman character. And there I select face DNA and save it, as well as selecting the body mesh DNA and also save this in my folder. In CLO I go to the file and then import, and then I select DNA. And now I can just like import the body and the face mesh. Hit OK. And now I'm going to CLO Connect in the top menu bar. I select it and switch from CLO to Connect tab. I'm searching for a garment and I want it for woman and for free. And then I'm typing in long sleeve and select one of the items from the library. And I just add it to my look. And now, while I selected it, I have in the right menu, next to the 2D window, the option of auto-fitting. And as you see, a wonder is happening. It just auto-fitted. And I do the same again with the shorts I selected. And I also auto-fit this one and cleaning it up. I just want to have like a base style where I can start my design from. I cleaned up my pattern by deleting baselines and unnecessary curve points. I also added symmetry sewing to all pattern pieces. Next, I select my first reference image, the top view of the shoe, and align it with my garment. Using the polygon tool, I trace the internal lines and add ellipse shapes for the eyelet holes. And I speed up this part. To recreate the shoe shapes in the correct perspective, I add an additional pattern piece to trace the side areas. Then I clean up my curve points again, since fewer curve points means fewer lines I need to select later when creating internal stitch lines. And I continue by using cut and sew to divide the pattern pieces. This helps me to block my patterns and gives me a better visual overview of the different materials. Since I lost some symmetry during the process, I deleted one side and duplicate the other using Ctrl-D to restore symmetrical sewing. Because I'm lazy, I decided to use the front part also for the back side. I don't have a special shape, so I just copy, paste, and then place it on the back, and then sewing the panels together. Next, I move on to creating the laces. I simply create a rectangle and sew this shape to the eyelet holes. To position the laces correctly, I temporarily unsew the shoe tongue so I can place the laces above and below the shoe pattern pieces. To improve the simulation quality, I reduce the particle distance to 5 and increase the rendering thickness to 3. Then I adjust the sewing lines and duplicate my lace shapes. For the lace endings, I slightly trim the shape and reduce the width. After that, I attach the laces to the side panel. Once finished, I duplicate them to the opposite side. Now that the front section is finally completed, I copy and paste it again to reuse it for the back section as well. I sew the pieces together and add additional laces that connect the front and the back parts. Before moving on, I add top stitching details using the polygon tool or by selecting the lines, right-clicking and creating internal lines. Next, I start working on the pants. I take my top front pattern piece and copy just certain elements, align them with the design and add cut lines. At this stage, I only sew the front and side panels. Since I forgot to save my base long sleeve earlier, I had to recreate and adjust it to build the underlayer for the top. I then add additional design details and cut lines to the top. For the pants, I refine the shape and experiment with seam tape to create a more stable simulation. In CLO, I also add my stitchings and puckering to use the baked maps in Substance Painter. Later, I decided to separate the top and bottom into individual garments, and I arranged all pattern pieces for each style into a single UV tile using the Auto UV tool. For texturing, I use Substance Painter. I won't go into detail in this tutorial, but to prepare the garment, I block out colors using vivid tones. This allows me to create an ID map later in Substance Painter to separate my different materials. And then I save this version as my final look ID before I'm merging all materials. My goal is to have only one material slot per garment. After completing the texture in Substance Painter, I import the textures back onto CLO garments. At the end, I separate the look into top and bottom part. And before exporting the garment, I prep everything to export it later with SIG garment values. To achieve this, I assign different values to my pattern pieces. And normally I use extrusion in both directions, but in my case, some of the pattern pieces just sitting on top of the garment, so I can also change the setting to forward or backward. And I also enable UV extension for the face side, because this helps to continue the textures outside of the UV tile, and it prevents stretching of the textures. I have to say the garment is not fully optimized for gaming, but compared to my older workflow where I used often double layers to create an organic look and drape on the garment, this workflow actually produces much cleaner pattern pieces and is better for exports. Using the Auto UV, I use a distance of 0.01 and a fidelity of 5 to arrange all my pattern pieces into the first UV tile. For Unreal Engine, I'm actually using a single material slot, and I assigned the physical properties of leather full grain. For texture maps, I imported my color, my normal, my metal, and my roughness map from Substance Painter into CLO. And to optimize my garment for real-time simulation in Unreal Engine, I need a low poly garment, so I assign all my pattern pieces not lower than 10. And even for the laces, which I want to weight paint and real-time simulate them in Unreal, I use a value of 12. I tested it and it worked really well, while when I was going to a lower particle distance, it was breaking and not moving at all. So if you see any issues with your garments, probably you check first like the poly count of your garment. One last important step for weight painting in Unreal Engine: the weight paint window does not display the UV tile layout. It's showcasing the 2D pattern window. This is why I arranged already my pattern pieces that I can easily paint later my laces in once. So I place them separately to the side. And now we can head over to Unreal Engine. In Unreal Engine, I prepared this scene in advance. If you're interested, you can find the full project file as well as a scene setup tutorial in the link below or in my channel. Next, I switch to live sync mode and adjust the following settings: single object, thick, unified UV, include garment simulation data. I also deselect avatar and flip green channel. Then I hit the update button. A garment preview should now appear in the 3D window. Next, I save the garment as a cloth asset. I create a new folder and press Save. The garment disappears, but a new folder is created. Inside that folder, I find the cloth asset, which I open with a double click. Inside this very irritating node system, I select the first node where the USD import is already set up, so I don't need to do anything. Then I move to Transfer Skin Weight and select my SKM body mesh in the Details panel on the right side. Next, I open the Weight Map Max Distance node and begin weight painting. Black or value 0 means no movement, while white or value 1 allows full movement. On the left side, I can adjust the brush strength and shading. I start by painting the lace endings by selecting them. Then I adjust the brush size and paint the laces. To create smoother transitions, I switch the brush mode to smooth to generate a soft gradient. Once finished, I accept the changes. In Simulation Max Distance config, I change the max distance value to 40. Next, I move to Set Physics and assign my MetaHuman physics assets as a collider for the garment. Now I can already preview the simulation using the Play, Pause and Reset button in the simulation preview window. Then I switch to the Preview tab, select my avatar body and choose an animation to test the garment. Oops! If the simulation doesn't behave correctly, I go back to Transfer Skin Weight and change the transfer method to closest point on surface. After that, I move to the end of the node graph and delete LOD 2. I select LOD 0 and adjust the simulation values to achieve smoother cloth behavior. Now I can save and close the window and open my MetaHuman blueprint. I drag and drop the cloth asset onto the body and make sure it's positioned below the body mesh in the hierarchy. I repeat the same process for the bottom as well. Finally, I created a sequence including my avatar and an animation. To preview the simulation, I press the green play button at the top. Then I play the sequence to see the animation running in real time. To stop the preview, I press Escape or click the Stop button. You probably noticed that the shoes are still missing. I decided to rig them directly inside Unreal Engine. The setup in CLO is basically the same as for my garments. Inside CLO, I position the shoes correctly on the avatar and make sure the textures and UVs are properly prepared. Next, I switch to Unreal Engine and open the LiveStick plugin. I keep the same settings as before and press Update. This time I save the import into a new folder. Inside that folder, I open the static mesh. I right-click the static mesh and convert it into a skeleton mesh. In the conversion settings, I select existing skeleton and choose my MetaHuman body mesh. Then I open the skeleton mesh. In the left side menu, I select weight transfer. I scroll down and open the tab menu. Select the mesh again. Transfer the weights and accept the changes. Next, I open my MetaHuman blueprint and add the skeleton mesh below the body component. And that's a complete workflow, from claw garment creation to Unreal Engine, setting up chaos claws, as well as rigging the shoes. If you enjoyed this tutorial, consider subscribing to my channel. This would be already a big help for me. You can like this video and also leave comment with questions or any other feedback. I'm always happy to answer all of them. You also find on my channel more videos like this as well. In the link below, you find access to templates and content I'm selling in my shop. Thank you so much for watching and see you next time.